Hypotheses, theories, and laws. Okay, let's start with this. Laws and theories are distinct instruments used in science. They serve different purposes. Neither is better, more solid, or more accepted than the other, and neither changes into the other. Very much like, for example, a pick and a shovel are two distinct tools to use in the garden. They serve different purposes. Neither is better, more solid, or more accepted than the other. Neither changes into the other. They serve different purposes. That's all. That's the way laws and theories are. Now, the interesting thing is, both laws and theories start as a hypothesis. That's the start of both of them. Laws and theories, they start as hypotheses. And both of them are supported by a lot of data, a lot of evidence. And both of them can be adjusted or altogether rejected if new data, due to the emergence of new tools, insights, or technologies, challenge the current understanding. If something new challenges the current understanding, challenges the current law or the current theory, the theory or law can be adjusted or altogether rejected. Data rules. That's the way it goes in science. Data is the most important thing in science. Be careful with the common day use of the word theory. In the common day use of the word theory, we hear of something and you say, I have a theory about that. Actually, what you talk about when you say I have a theory about that, you are talking of a hypothesis. A hypothesis becomes a theory when it is supported by lots of data and when it is an explanation, when we'll talk about that later on. Okay, but anyway, common day use of the word theory is hypothesis. Just be careful. Theory in science is much more solid. It is a hypothesis that turned into a theory by being supported by lots of data. Now, so what's a law? What are laws? They describe specific natural phenomena without explaining them. They just describe. They tell us how science is, how things are, how nature is, how things are. They don't explain anything. Now, it tells us the how, not why. How nature behaves, not why. Laws are supported by extensive data. It becomes a law only when it is supported by lots of data. Think of example laws. I'll jump here first. Think of example laws. Newton's laws of motion. An object at rest stays at rest. An object moving at a constant speed in a straight line will continue moving at a constant speed in a straight line. That just tells us how things are. That does not explain anything. That's what makes it a law. And it is a law because it's supported by lots of data. Similarly, law of conservation of energy. Energy can never be created nor destroyed. Again, there is no explanation there. It just tells us how things are. Remember, laws can be changed or altogether be rejected. There is nothing sacred in science. If challenged by new, replicated, and verified data. If there is new data that is replicated and verified that challenges a current law, that law can be changed or altogether rejected. And remember, laws are not better than theories. They are a different tool. They just describe. Theories do not just describe. And laws don't become theories, and theories don't become laws. Now, here is what theories are. they explain natural phenomena that were previously verified and supported by extensive data. So natural phenomena that were observed, that were agreed upon, that had a lot of data to support them, but we had no idea why they were so. And then someone comes about and proposes a hypothesis to explain that data. So that hypothesis, once it is taken up by the scientific community and challenged and tested again and tested again, if that hypothesis is supported by extensive data, then it becomes a theory. So theory is the key word. They explain a range of natural phenomena. Now, again, like laws, theories can be changed or altogether be rejected if new, replicated, and verified data emerges. And again, theories are not better or worse than laws, and they don't become laws. Now, example theories. I'm going to talk about the main one, Big Bang Theory. For example, before the Big Bang Theory came about, scientists have observed and verified and replicated that the universe is expanded. All scientists were in agreement due to observations that the universe is expanded, was expanding and is expanded. They had no idea why is it doing so. Also, there is replicated and verified data by a lot of scientists that shows that the universe is mainly made up of hydrogen and helium. All the other elements make up less than 1% of the elements in the universe. The universe is mainly hydrogen and helium. Again, that's accepted, known, but we had no explanation for that. Moreover, when you use microwave detectors, scientists have observed that there is microwave background radiation throughout the universe with no particular direction. It exists everywhere in the universe, throughout space, and we had no clue why do we have that microwave background radiation. Okay. Now, all of these were findings that scientists agreed upon, that are supported by extensive data. And then someone came about and said, I can probably explain all of these if I assume that the universe started with a big explosion. And he provided an explanation on how that explosion can explain all of these phenomena. Of course, scientists from all walks of life got that idea. Some of them questioned it. For some, it seemed interesting, but they came up with hypotheses to test that idea. But once that idea was tested extensively, it came to be known as the Big Bang Theory. So once it was supported by lots of data, that's when it became the Big Bang Theory. Another example that's talked about in depth in the course, plate tectonic theory. People knew that the continent looked like part of a jigsaw puzzle. That was known. Also, scientists have found that we can find same fossils and same rock layers in distant continents. When looking deep in the ocean, scientists have found out that actually the seafloor is spreading. Seafloor is growing. We have new crust in there. Also, the data shows that earthquakes and volcanoes occur in specific locations on Earth. All of these were data that was known, that was verified, that was replicated, that was agreed upon by scientists. And then someone came about and suggested as a hypothesis, we can explain all of this if we think that the Earth is made out of plates that are moving. And he explained all of this, all of these phenomena through this motion of these plates. Again, scientists thought that was interesting, and some of them questioned it, some of them doubted it, but a lot of them tested it. When enough data came about, it supported that theory, and that's why it is the plate tectonics theory. Okay. Now, what's a hypothesis? A hypothesis is an educated guess about an observation, findings, or data that is testable, that we can test. Look here at the word testable, I say falsifiable, because they mean the same thing. Just be careful with the term principle of falsification. It's much to do about nothing. Don't be taken back by the word falsification. Falsifiable or falsification means testable. Just think of it that way. If you think of it that way, you'll be fine. Don't try to come up with false in the answer or whatever. Come up, check the answers for the one that tells you that it is testable. For example, while I'm recording this, let's say I hear a noise on my attic and I say, I think I have ghosts on my attic. Okay, now, is that testable? Is that falsifiable? Now, if any person on Earth can come up to my attic and check out if there are ghosts or not on my attic, then that will make it testable. As it happens, only a few of us claim to be able to watch ghosts. Science cannot be relied only on a few people. Any person on Earth with the right equipment should be able to find the same thing. So that idea is not testable, so it is not falsifiable, it's not a scientific hypothesis. Now, if I say instead, I think there are rodents on my attic, that's a different story, because any one of us can come to the attic and can check, can possibly see rodents, or can see droppings from rodents, so they can, anyone on Earth should be able to test whether or not I have rodents in my attic. So that's testable, that's falsifiable.